The final question is a paper 3 data response type question, all about cooling of oil inside a can. A graph is shown of temperature over time, and the first part of the question asks you to draw a straight line which is parallel to the time axis to represent the temperature of the surroundings. Well, it tells us here the surroundings are 26 degrees. So, nice easy question. We have to find 26, which is 20, 30, about here. Okay, and then draw a straight line along from there. Whoops. You get the idea. Part 2 then asks us to draw a suitable tangent in order to calculate the rate of decrease of temperature for an excess, now that's really important, excess temperature of 50 Celsius. So we have to add the initial 26 degrees onto that. So we're looking to draw a tangent to the curve at 76 degrees. So if we find that on here, we've got, that will be here, just where that blue dot is. When drawing a tangent to the curve, try to make sure there's an equal angle on both sides of the point at which you're measuring the tangent from. So there we go. It's not great, that line, but it's about as good as I can do on here. And what I mean is that the angle here is roughly the same as the angle here. You then need to calculate the gradient of that line by doing rise over run, or y2, y1 over x2 minus x1. The largest triangle, use the largest triangle possible. That ensures that to improve the accuracy of your gradient. In addition, you do need to take care, because it asks for, in the question, it does ask for the time to be, or the gradient to be in degrees C per second, whereas the time is given per minute. When you do that, you should come out with a gradient of between 0.09 to 0.13. There is one mark for a bit of additional precision, so if you're between 0.1 and 0.12, you get an additional mark. The next part of the question shows a graph of the rate of decrease of temperature change per second against the excess temperature of the hot oil. The first part of the question asks us to to plot a data point corresponding to the one that we've just calculated from the tangent. I'm going to go for a point at 0.11, which is right in the middle of the accepted range, but yours could be any, as long as you plot the value that you had earlier on, that would be acceptable. So 0.11 is roughly there. Part 2 asks us to deal with the uncertainties of the graph, only on R though, so we're only having to deal with it in the Y direction. It says that there is an uncertainty of plus or minus 10%, and it asks us to plot it for 20 degrees and for the point at 81. If we deal with the 20 degrees first, you could look at the value here of R and then work out plus or minus 10%, but it's perhaps easier just to notice that this is 11 squares up to here. So 10% of that is 1.1 squares. So all we need to do really is plot just over 1 square in each direction like that. It's a little tricky to do on here. Hopefully yours will be a little bit neater. For the one at 81, we can do the same thing. So that is going to be 47 squares up, 47.5 squares up roughly, which means that we need to have a plus or minus approximately 5 small squares in each direction. So something a little like that. Part C asks us to verify this relationship between R and theta E, whereby we would expect this to be a linear fit between R and theta E with no intercept. There's no plus C. If we look at the graph on the previous page, it is a linear fit. It doesn't appear, just the data points alone don't appear to be going through the intercept, but with the uncertainties, so accounting for the uncertainties, the data could well go through the origin. So accounting for uncertainties, we have a linear fit, and goes through origin, which verifies that relationship. Part D then asks us to plot a log-log graph, or sketch a log-log graph of R against E for a different experiment. Now, whenever we plot a logarithmic graph, we're going to end up with a straight line, and in this case it's going to have a positive intercept as well. The reasoning behind that is asked in the second part of the question. It says, assuming the expression in C part 1 is correct, state the gradient of the line of the graph. Also explain how the value of k is obtained. Well, whenever we plot a log graph of two variables like this, the gradient should give us the expected power relationship. So here we can see that r and theta, there is no power relationship there, so we'd expect the gradient to be equal to 1. In attempting to verify the relationship, we've just plotted a log-log graph of each side. So we've done log of r equals log k theta e. But the rules of logs allow us to separate this out into two expressions. That becomes log of k plus log theta e, which means that the intercept of our graph should be equal to log k.